Before we do a new lecture, let's see this example. This example says that x can choose 998. So you see x gets bigger and bigger, goes to positive infinity. If x goes to positive infinity, where does this one go? The negative 14 over x plus 2, where does this one go? If we let this one be y, where does y go when x goes to positive infinity? Okay, you plug in 8 here, and negative 14 over 8 plus 2 is negative 14 over 10, which is negative 1.4. When x is 98, you plug in here, negative 14 over 98 plus 2, which is negative 14 over 100. You will end up with negative 0.14. If x is 998, you plug in, you have x is you have a negative 14 over 998 plus 2, which is negative 14 over 1000, which is negative 0.014. You see, when x gets bigger and bigger, y equals this big quantity gets closer to 0. You see, more and more decimals. Yeah, that's the point I want to make. Okay, x goes to positive infinity, y, or this irrational expression will be going to 0, close to 0. Okay, so I will use this one in the following lecture. In this lecture, we will talk about find the oblique asymptote for the function and sketch the graph. The given function is f of x equals x squared minus x minus 20 over x plus 2. We want to find out oblique asymptote and graph this rational function. This is a rational function, so step 1, locate the 0 point for denominator. Okay, this will give you the vertical asymptote. We know if we plug in negative 2 here, negative 2 plus 2, you get 0. So 0 point here for denominator is negative 2. X equals negative 2. So that's the vertical asymptote. Okay, so we find out vertical asymptote. Since here numerator, the exponent of numerator is 2, the exponent of denominator is 1, 2 is greater than 1, then we don't have a horizontal asymptote. We only have an oblique asymptote. How to find out? Here is the way. You see, it's basically numerator x squared minus x minus 20 divided by x plus 2. You do division. Okay, details are here. You put x times x, x squared, x times 2, 2x. Top one minus the one below, negative cancel, negative 2x, negative 1x, together negative 3x. Negative 20 moves down. You need negative 3 times x, give you negative 3x. Negative 3 times 2 give you negative 6. Minus the following one, change the sign all to plus. Cancel that. You have negative 20 plus 6, which is negative 14. So I just want to recall it. 106 divided by 8 equals 13. Numerator is 13. And the quotient is 13. Okay. So then you basically, how did we get that? You put 1 here, 8. You have 8. 10 minus 8 is 2. 6 goes down. 3 times 8, 24. 26 minus 24, you have a 2. So you may write 106 equals 8 times 13 plus 2. Divided by 8, cancel this 8. So you have 8 over 2. Similar to this one, 106 equals 8 times 13 plus 2. Here is the same. X squared minus x minus 20 equals x plus 2 times x minus 3 plus negative 14. If you divide both sides by x plus 2, okay, then x plus 2 will cancel each other. The right hand side left over is numerator. So is the quotient right here, quotient. And then here is minus 14 over x plus 2. That's the right hand side. The left hand side is just x squared minus x minus 20 over x plus 2. Okay. So look, it's basically this one is the one here, and is the one can be written in this way. Previously we said, recall, when x goes to infinity, this one goes to 0. That's what we wrote here. X goes to infinity, you have this quantity goes to 0. So x goes to infinity, this big quantity goes to 0. Then you have a x minus 3 left, because this one is close to 0. You don't need to count. So when x approaches infinity, you have a y equals this big one is actually equals x minus 3 without that. So that's y equals x minus 3. That's a line, linear function. And this linear function will be the oblique asymptote, because when x goes to infinity, and then the whole quantity will approach to this line. This y will approach to this x minus 3. Y equals x minus 3. That's the oblique asymptote. Okay, so we got vertical asymptote, we got oblique asymptote. We want to sketch it. How does it look like? If you let x be 0, and then y equals 0 minus 3, 0 minus 3, that's negative 3. So x is 0, y is negative 3. Then you have a 0, negative 3, 0, negative 3 on the line. If you let y be 0, then 0 equals x minus 3, plus 3 on both sides, cancel positive, negative. X equals 3. So x is 3 when y is 0. So you have a 3, 0, this point on the line. You have 2 points, you connect it, that will be the oblique asymptote. So basically you find out oblique asymptote is by division. You can also use the synthetic division. Okay? Right here I use the long division. So after you find out the oblique one, oblique asymptote, you sketch it, find the 2 points like that. So for the rational function, most important thing is that you need to find out vertical asymptote, horizontal asymptote. If we do not have it in this case because of exponent of numerator, the highest one, is greater than the highest degree of denominator. One more than that. Here is 2, here is 1. By long division, you have here this equation is y equals x minus 3 for this dotted line. That's oblique asymptote. So you see vertical one, oblique one, they intercept here. Now, step 3 is to find out 0 points and sketch the picture. To find out 0 points, we need to factor numerator. Again, right here, negative 20 is negative 5 plus 4 times 4. Negative 5 times 4, you get negative 20. Plus each other, you get negative 1. So numerator can be factored into x minus 5 times x plus 4. Denominator is x plus 2. Now you have a here is negative 4, not here, negative 4. Negative 4 right here. So here is negative 4, that's the 0 point, and here is 5, that's the 0 point, because you plug in negative 4 plus positive 4 cancel each other, you get 0 for this quantity. 0 times any quantity is 0, and numerator will be 0. If numerator is 0, the whole quantity will be 0. So negative 4 is the 0 point, so is 5. X equals negative 4 is right here. X equals 5 is here. And negative 2 is a vertical asymptote. You basically have 3 points. Negative 4, negative 2, and 5. Okay? Negative 2, negative 4, and positive 5. Those 3 points divide x-axis into 4 parts. One part from here, 5, to the right. Negative 2 and 5, that's the second part. And between negative 4 and 2, that's the third part. And between negative 4 to the left, that's the fourth part. Again, you want to test among those 4 parts, where is positive, where is negative. Okay, so choose another point bigger than 5. Here I chose 8. If you plug in 8 here, 8 minus 5 times 8 plus 4, and here is 8 plus 2. Denominator is 10. 8 minus 5 is 3. 8 plus 4 is 12. 3 times 12 is 36. Divided by 10, 3.6. So when x is 8, you have y is 3.6. So 8 is right here for x, y 3.6. I probably need to put this one down a little bit. Let's see. 1, 2, 3. Yeah, this is the correct point. So I should put 1, 2, 3 here, and 3.6 is slightly higher. So 8, 3.6. That's positive. 1 point is positive, and you know this is a 0 point. Okay, you connect it. Actually, if you have this one, this part is positive, then between these two, you know for sure is negative. But we pick a point, easy point will be 0. Okay, between negative 2 and 5. You pick 0 for x, and then you put in here 0 squared minus 0, 0 squared minus 0, minus 20. Here 0 plus 2, and upstairs has negative 20, downstairs is positive 2. So the answer is negative 10. So x is 0, y is 10, negative. So then you know 0, x, negative 10, that's this point. So you can connect this point with this point. So basically you have 3 points is like that. And then you can see when x approaches -2, this line approaches dotted line but never touch this line. So that's why we have a vertical asymptote here. And when x goes to positive infinity, this line can be very close to this dotted line but never touches this line. So this line will be the oblique asymptote. Okay, now we are clear about these 2 parts. Then we need to be clear about this part and the part on the left of -4. We choose -3. Okay, between this -4 and -2. -3 you plug in. Okay, so 3 negative minus 5 -3 plus 4. -3 plus 2, then you have a -1 denominator. -3 -5 is -8. -3 positive 4 is 1. So 1 times -8, downstairs is -1. So you have 8. Okay. Now -3 positive 8. Where is that? -3 positive 8. Very high. Here is 3, and you know here would be 5, 6, 7, 8. So very high here. -3, 8. Okay. So then you know -4 was the 0 point. You plug in -4 here, you get 0 for this quantity, whole numerator. That's why. So you know here -4, 0, this point, you can connect it. Again, here is positive on this part between -4 and -2. Then you know on the left will be negative. Let's pick up -6 to calculate. To pick up -6 is as things we did here. -6 is like -3 here. -6 minus 5, -6 plus 4. Here was -3 plus 4. And here -6 plus 2 was like -3 plus 2. So downstairs you have a -6 plus 2 is -4. Upstairs you have -6 minus 5, -11. -6 plus 4 is -2. 3 negatives make a negative. And then you know here is -2, here is -4, so you have a negative. You have 2 here. So the answer is -5.5. For x equals -6, you have -5.5. So this is your y. When x is -6. So -6 for x, and y is -5.5. Okay, here is -5. Okay, yeah, 1, 2, 3, 4, 5. -5. And -5.5 will be done here. So -6 for x, -5.5 for y, this point. Then you can connect. Okay? You can connect those 3 points. Then you know on the right hand side of the vertical asymptote looks like this. On the left looks like this. And this line will approach this asymptote as close as we want it, but never touches this dotted line. Okay? Again, here there are 3 main steps. Step 1, 0 point for denominator, you can locate vertical asymptote. Degree is bigger than denominator. The degree of the denominator, numerator is bigger, so you have oblique asymptote. Find it out by long division or synthetic division, and then sketch it. Here are the details to locate 2 points. Okay. Now, step 3, factor the numerator, and then you have 3 points, 5, -4 at 0 points, plus the 0 point for denominator. So 3 points divided 9 into 4 parts, and then test the value in these 4 parts. Okay, you always want between -2 and 5. You always want to choose when x is 0. You'll find that y-intercept is -10 in this case. Okay, you have 1, 2, 3, 4 points besides 0 points. So then you can find out the picture. Okay, I'll see you next time.